All right. Welcome, everybody. It's been a long time since the last live stream. A lot of things have happened since then, a lot of changes, and I'm happy to finally be able to get back on here and do something. So I didn't really do any notification or tell anybody that this was happening today. I just kind of decided I've sat on this long enough and it's time to get it open and actually working for me instead of sitting in a box on the table. So I'm going to give it a few minutes of just kind of putting around and not really doing much of anything and see if a couple people join up. And hopefully that'll make things a little bit more interesting as far as content-wise. People can ask questions, make comments, or whatever they want. So here's to hoping for that. Thank you very much for tuning in today, though. I appreciate it. And just to give you a heads up, what we're going to be doing today is unboxing a new piece of machinery that we have gotten our hands on. Got our hands on a couple months ago, actually, and haven't really done anything with. So I'm just kind of hoping that we have a cool experience opening this up and getting it set up and maybe even using it for the first time. Let's see. All right, cool. Sounds like my voice is actually coming through. So that's good. Just wanted to check that out real quick and make sure my mic was working and everything's streaming well. So welcome. It's Friday afternoon. We got a new tool to unbox. Hopefully this will go smoothly and I don't look like too much of a jackass. But just as a heads up, to let you know, I have zero experience with this. This is a whole new field, as you know, by the name Beam It Up Laser Works. My primary focus is lasers. This guy is not a laser. It is another what I would call like a maker tool or whatever. But I guess I can just show you what we're looking at here. It is upside down. This is a Genmitsu CNC. So it's a CNC mill, comes with like a 710 watt spindle. I kicked around several different machines. Couldn't really make my mind up. There were some that had more size that came with the weaker spindle. So I could pay extra money for the extra size and then pay extra money for the extra spindle, or I could get this one that was a little bit smaller but came with a more powerful spindle and has an extension kit that I kind of wanted to order and get here before this, but I'm tired of waiting. So what we're going to do is set this up, and I was hoping with the extension kit what I could do is just throw the extension kit on while I'm doing the initial build instead of having to build it, test it, and then it will ultimately take it apart, put it back together with the extension kit on it. But this is a 3018 machine, so it has a 30 centimeter wide by 18 centimeter deep by like 3 inch, so 70 something millimeter high workspace. Pretty good review. Genmitsu does make some good machines. They're usually typically pretty well built, and that's mostly what I was looking for, was something that was well built. And then a lot of this stuff is more or less like universal plug and play, where if you get one part that needs replaced, then it's fairly universal and you can throw different pieces at it and stuff and upgrade controllers. The one I was originally looking at had a 3-axis or 4th axis rather. This one, the controller doesn't have a 4th axis, but I can upgrade the controller later on down the road and add that 4th axis capability. So this for me is kind of like my first dipping my toe in the world of CNC milling and machining, or whatever you want to call it. And yeah, so I guess we can just get started. Take my trusty SOG out. And as you can see, this is all taped up still. Like I am breaking the seal. Almost broke the seal on my glove. Jeez. Guess that's why they always said don't cut towards yourself, right? Breaking all the rules already. I'm sure this is going to be a really safe and productive live stream. All right, so we got that. There we go. Let's go ahead and sheave the old sag. And I apologize that this is all upside down to you guys. I guess I didn't really think that out. I know there's a way to invert my camera, but I think I have to go into the software to do it. And I don't feel like I have time for that today, or the patience, really. So, as you can see, I'm not in my workshop anymore. I had some situational changes with family stuff and needed to be spending more time at home. So I made the tough decision to vacate my workshop and move back into my garage and kind of do the laser stuff on a more limited basis and pick up kind of a part-time. So that is why I am in my garage today. So taking off this top piece of foam, you can see this thing's really well packed. I mean, we've got nice, thick, sturdy cardboard, nice foam padding. Everything's kind of stuck in here nice and neat. Looks like we have some bits here, I think. Not quite sure. Let's find out what they are. Ooh. Oh, yeah. So like a V-bit. So yeah, good. It came with four 10 bits. Not bad. I did buy from Jinmitsu also a 40-bit kit, I think it was. They're all like 1/8-inch bits. And then from a different company, I bought, I think, 2 1/4-inch bits that are specifically designed for like removing steel and stuff. So this is the base plate. So as you can see, this is our roughly 300 millimeters of side to side and roughly 18 centimeters of back and forth. And this is one where the bed itself is going to move, as you can see with the screw lead here. So it has the bed movement for your y-axis, and then the spindle moves left and right for your x-axis movement, and then it'll have the z, obviously the spindle moves for that as well. So boom, there we go. We got the base. Set that to the side. Our typical USB type B connector, kind of like you get with a DeskJet printer or with any number of lasers that I've bought over the years. So USB type B. Take the next layer off. Oh yeah, I was picking at that, trying to pick it out. That wasn't going to happen because that's our Z chassis. So here we are with our parts kit. Really cool that it comes with a Z probe. That's nice. And then it labels everything as far as what is coming with what, which is a pretty handy thing to have. Looks like some replacement, maybe end limit switches, rather. I was going to say end stops, but those would be limit switches. Or maybe those aren't extras. Maybe I have to add them. I don't know. We'll see. I'm sure the instructions will tell us. We have 2 power cords. We have a controller, which is cool because then I can actually, I believe, yep, has a SD card slot here, so I can insert an SD card and run things off the controller and be able to do things without having to have a computer hooked up to it. And we have a output 24 volt 5 amp power supply. Starting to run out of table already. That's not a good sign. We have the collar, and it looks like maybe an adapter, or I don't know. But this obviously is what we'll hook up to these over here, and our spindle will go into. I think this is an adapter to make it so it'll fit like I think a 70 or a 50 is what it is how it was supposed to be, if I remember correctly. But keep in mind, it's been a couple of months since I ordered this, so my memory is already terrible. Add a couple months of forgetfulness on top of it, and yeah, it's a recipe for not knowing what the hell I'm doing today. So I apologize. If you didn't have a very high opinion of me before today, then you're probably really going to enjoy this. And if you had a high opinion of me before today, then this might be painful for you to watch, because I'm literally doing this from an aspect or point of view of pretty much anybody who just kind of knee-jerk buys a freaking CNC, doesn't know much about CNCs other than to buy a good quality machine. And now I am going to put it together and try to figure out how the hell to run this thing. And I have not really studied anything to do with any of this. So, yeah, like I said, if you don't have a high opinion of me already, you'll probably enjoy today. And if you thought of me highly and thought I was smart, then your opinions might change rather quickly. So we're going to set the spindle off to the side. Like I said, I upgraded. Well, I didn't upgrade. I opted for the upgraded spindle, which is a 710 watt spindle. I don't know quite what that translates to as far as like horsepower, because I know a lot of the ones that are advertised, if you buy like a router or whatever, they're listed by horsepower a lot of times, and I'm not sure what 710 watts translates to in horsepower, but I don't think it's a quarter or a half. I don't know. I'm just gonna say I don't know and leave it at that, because that's the God honest truth. All right, so we can set the box off to the side, set our X chassis here. I think that'll be fine. Set our controller over here for now. We're not going to need any of these cables as of yet. And here we are with our instructions, etc., etc. So as I mentioned, this is the Jinmitsu. This is the 3020 Pro CNC router kit. So again, I apologize. This is all going to be upside down, so you're not really going to be able to like read along with me or anything. But work area 300 by 205 by 78, not 178. 178 would be pretty cool, but yeah, nope. 300 by 205 by 78. So the unboxing shows all of these pieces here. I did buy a 1/4-inch collet, so that's good for using 1/4-inch bits. So it gives some overall dimensions. Offline controller cable. I do not recall seeing the offline controller cable anywhere. Oh, you know what? It's probably... Oh, yeah, it's listed right there. Cable of offline controller. So this must be it. Yep. All right, cool. Woo! Got a little nervous there for a second. All right, so this is our call it. We have a thumb drive with an SD card in it, so you can upload your stuff into the SD card and then take it out and put it in the controller. Some simple wrenches, Allen wrench, some zip ties. That's nice to have. And then the metal clamps and hold downs, Z-probe, some feet. And then the various screws for assembly. So that's what we're looking at now. The assembly should be pretty straightforward. I can't imagine there's much I could screw up on it, but let's just take a glance. So we got T4 nuts, socket screws. Oh, okay. So just put the feet on the bottom with your M4 by 10s, which are those guys, right? Yep, M4 by 10s. All right. So move this over here. And just to reiterate, it looks like we got our first viewer in, and today we are assembling and going to try to first use our new Genmitsu 3020 Pro, Max Pro, not Pro, no, Pro Ultra, that's right. The Pro Ultra. The Max Pro is the larger one. The Pro Ultra is this unit, but it has the 710 watt spindle versus I think the other ones come with like a 300 or 500 watt spindle. So welcome, viewer, whomever you are. Oh, here we go. Kevin Murphy 2300. Good afternoon, Anthony. Good afternoon to you, Kevin. I'm glad you could make it. I didn't really announce this or put too much into it because I know today's probably going to be kind of a goofy disaster. And I kind of partially thought the fewer people that see it, the better. But, you know, que sera, sera. So let's see. Do these go in twists? Okay, so it's going to stay that. Normally I remember these sliding in. Am I supposed to slide those in? Or will it just kind of... All right, I guess we're going to look at the instructions. So, yeah, it just says to attach them. It doesn't really say much of anything else. There's not a place to slot them in. So if we take the screw... and then the T... And it's typically the way those nuts work is you put them in on the end, right? Because it's not going to spin unless you make it spin. Oh, look, had something going. There we go. All right, I guess not. Good. Let's tighten that a little bit, and we have 3 more feet to go. So yeah, I picked this machine because I want to be able to do metal a little bit more quickly than with the laser. Lasers are great. They will ablate metal. You can use them to cut metal. They're not ideal for the job because, well, for one, my fiber laser is a galvo laser, and galvo lasers move out in a conical pattern from the center of the lens. So if you're trying to cut something that is getting close to the edge of the field of the lens, which is really what you want, because you want to be able to use the smallest lens possible so that you have the most energy density possible. Otherwise, you're going to have too much lens and not enough power you're laying down with the larger lens. Either way, trying to cut with a laser is just not optimal. Well, at least a galvo laser. I mean, like all the good cutting systems are on a gantry so that the beam can move straight down and it can be optimized to keep the focus. So having something like this to do faster metal removal and be able to make like jigs for like, I don't know, say coins or business cards or anything that kind of pops up. Like I just had to make a jig the other day for a cross that a lady had asked me to engrave for her. And basically what I was just trying to do was have the cross sit in this jig while I'm engraving it, and I just cut a semicircle in the jig or in the piece of like wood and then bolted it to my laser bed. And that way I knew that if I had to move this thing that it would stay aligned because it would rotate inside the semicircle. So it made it so that it was a little bit easier to get the job done, and just being able to like quickly make jigs. That specific one I didn't really need the CNC for, but some other ones, some other jobs that might pop up here and there could possibly, need that. So I'm kind of hoping that this will come in handy for those, and especially the coins, and then being able to do different size coins. So and then I have some ideas for like jigs to help you like be able to flip a coin and engrave the opposite side, stuff like that. So I don't know. It just kind of, and then people are often asking me to cut metal. The extension kit that I mentioned earlier would make this a 300 by 300, I think, or no, it'd be a 300 by 400 millimeter bed. So instead of being 30 centimeters by 20 centimeters, it'd be 30 centimeters by 600. And that would make it so that I could cut metal and different things like that much larger in footprint than this, and really larger than anybody's ever asked me to so far. So I think that this will be sufficient. It'll be a good learning machine, something that I hopefully won't grow out of too quickly. But again, like I said, a lot of this stuff, this is just extrusion, so if I needed to make it bigger or do something different, then buying more extrusion, or, like this backing plate here is actually a pretty beefy boy. So I don't know if it would be easy to just get a new backing plate and make it wider. But I mean, there's expansion, flexibility, and, just in general, I think this is a good machine to start with. And if I make my money back with it, or it proves to be a good investment, then maybe down the road I can look into getting a larger or different machine. I don't know if I'll ever need something like, the big tabletop units that people have that are like multiple feet long by multiple feet wide, but you never know. I never thought I'd need a 50-watt fiber laser, so there's that. Or a 5-watt UV, or any of them, really. Son of a gun. This little T-nut doesn't want to turn too much. This is probably taking a lot longer than it should, just because I keep yapping. So if you've ever wanted to get a CNC, hopefully maybe this will help you with your decision. I don't know. Hopefully, at the very least, it won't dissuade you from getting one. Just remember that I'm not a trained professional, and your results will probably hopefully be far better than mine. Why is this not want to twist? Because I put it in upside down like a dummy. Is that why? I think that might be why. I think I flipped it over on accident, not paying attention. There we go. Hey, look at that. We're getting grip. Shocker. Like I said, if you had a high opinion of me before, that might change by the end of today. So, all right. So we have our feet on our base. And it appears that the next step is to just attach the chassis to the bottom. So, yeah, there's the 16 M5 by 25, which are these guys. So there's 8 on this side. And you can see this isn't with the T-nuts. It's actually drilled into the frame itself. So that's good. I hope you saw that. If you didn't, we'll try it again. Oh, yeah, you can. Okay, good. All right. So we just take this, set you over here. Yeah, that's a nice snug little fit right there. And it does sit a little bit lower. So what we can do is try and fit something underneath to kind of shim it up a little bit. Or what we might be able to do is just thread one in on each side. So I have this guy, and what we want to do is get that kind of right there. There you go. So if you lean it back on this corner right here, then you can actually kind of like line up the hole, and then we'll be able to like cantilever the back up and get the next one in. So there we go. All right, now we can use the provided hex key, and because it's getting a little hard to manually do it. So we can just kind of get these so that they're more or less not tight, but a little bit snug. There you go. Back to this side. Oh, we got a second viewer. Good to see you. Glad you made it. Sorry I didn't really make much of an announcement, but yeah, I was kind of hesitant to even do the live stream, but I promised a live stream so that people can watch this, and then somebody who may be smarter than me, who might be thinking about buying one of these machines, can be like, oh, well, if that guy can do it, then I can definitely do one of these. So I want to have the material out there, but felt bad for people having to suffer through this process with me. So I'm trying to say is I'm sorry I'm stupid. Getting these in. 4 down, 12 to go. I mean, 16 is a lot of bolts to hold this together, but I mean, I'm not going to say that's overkill. I'd say it's pretty sufficient. and it's just kind of another sign that this is well built. I watched a whole bunch of like reviews and even a couple videos of people building these, but these were people with much more experience than me also. But one of the comments that they made was a lot of these make you use the T-nuts to hold it to the extrusion instead of having the pre-drilled holes. And they preferred having the pre-drilled holes much more than they preferred the T-nuts. It made it a lot easier for not only for assembly and probably for alignment too, because I think some of them came with like a template and you had to line the template up and blah blah blah, and just having the pre-drilled holes I think is like a fantastic idea, and it makes this just slightly more idiot proof for knuckle draggers like myself. I'm just going to start threading these bad boys in, not even finger tight, just kind of getting something in each hole, and we'll get this going. I feel rusty. It's been such a long time since I've even done like a stream like this or anything. I did a frequency video, I guess, a little while back that turned out okay, but for the most part, it's just, what is the cost of this? I think on Black Friday, I ended up paying like $480 or something US dollars for it. I'd have to pull it up to be able to tell or to remember for sure, but let's see. I can get my Amazon app up real quick. Go to my orders. All right, so the 3020 Pro. Excuse me just a second. I'm going to step away. Hello? Yeah, I'm good. Thank you. How are you? All right, sorry about that. I had somebody calling to ask about some work. So we were asking how much I paid for this. Let's go back and check. So right now, buy new is 609. Order details. So I paid for this and the bit set 552 out the door. I think it said this was 460, 487. So I saved 120 bucks or something like that. So yeah, 487 was the Black Friday price, and it's 609 right now. If you watch it, these prices pretty much fluctuate, so you should be able to probably find a pretty good deal on it. Use this little guy because that Allen key is already starting to kind of flex. They don't ever give like the best tools, right? Yeah, no problem. I'm glad you asked and glad I could answer for you. I was looking at another one that was like $100 more, but it had a lower powered spindle. And I think it was a 3030 or 3040. It maybe have been a little bit larger, but it had the lower powered spindle, but it did also come with a fourth axis ability. It didn't come with the axis, but it came with the ability to do a fourth axis. I figured the fourth axis was probably something I could wait on and just kind of get my three-dimensional CNC stuff up to snuff. And then if I still felt like I needed the fourth axis, then, that's something I could invest in later on. These are pretty, I think, easy to work on. And being able to, I think, upgrade the controller in the future is a possibility. So if I do ever want to add the fourth axis, then I think that shouldn't be a problem at all. Just replace the board. And the boards aren't that pricey. I think one of the biggest costs of this thing is just all of the aluminum extrusion that they make them out of. It's not like a super overly complicated type thing. And the controllers really, they're not really that complicated, I don't think. So I think it's just it has an extra port to do the extra thing, and that's about it. So, all right. So I think those are all torqued down sufficiently. It doesn't give you any torque specs, so I don't think that's going to be an issue. Speaking of the controller, you can see this is where it is back here. Oh, no, you can't see because I rocked it back too far. So this is the controller, and you have the power switch, the different connectors that we'll be hooking up today. Like this guy comes up here and attaches and all that. So this would be, I like how it's enclosed too, to keep from dust and debris and stuff getting into it. Some of the other ones that I looked at weren't, and that was one of the other things that kind of made the decision for me on this. It just seemed like this was a little bit more well built. They put a little bit more thought into it than some of the companies had. So that was one of the reasons I went with this. I've had a Genmitsu product before, and it worked really well. It was well built, so I'm not mad. Okay, so the offline controller goes in here. Up the probe. Okay. All right, so we'll use one of the zip ties they gave us. Figured cut this open instead of using my teeth, right? Like a savage. All right, so if we run this up here, all right, so think I did that kind of dumb, but it'll work. Again, cutting toward myself, but I don't want to cut towards the metal and scratch the metal or my knife blade. All right, so this is laser y-axis. So that's going to be this right here. Why do we have two? Let's refer to the manual. All right, so got a rubber feet on, it's connected, and it shows you pretty well all your connectors right here. So it shows you where each plug goes and all that. Okay, so one's the Y and one's the Z, obviously. So the y-axis is going to be in the middle, the Z is on the right. So, oh, but the Z is already plugged in. All we have is the Y. So why is it two plugs? Oh, one of them's probably for the limit switch. So XYZ limit switch. It's going to be these guys here. There's already two limit switches plugged in, as you can see here. There's already the X limit and the Z limit. So now the Y limit's going to go in this spot right here. And then the Y axis will plug it in there for the motor control, or for the motor itself. So we take this guy and we can plug in like this. And then plug in like this. Ta-da. Then we agreed that goes to the spindle. Now this spindle controller is, I think, for the lower powered spindles. The higher powered ones are simply you plug it in with a 3-prong, and then it has the on-off switch here, and then a speed controller here. So you go from 1 to 6. I'll have to look up the RPM settings on this and see how fast it's set to go, what each setting does. But yeah, so the spindle controller we're not going to use because we don't have that type of spindle. There are adapters, I think, that you can buy where you basically take this and plug it into another thing that is like a pulse width or whatever. It'll control the voltage to the plug so that it'll turn it on or off. So maybe it doesn't control the speed, but it will at least control the on-off function. So you can run a relay, basically, that this will control. And it'll turn the relay on or off and turn the spindle on or off so that you don't have to manually turn the spindle on every time you want to use the mill. All right, so I don't know if we're going to need that again anytime too soon. We do have to put our spindle holder on. So it looks like we have attached the gantry to the base. Now we have the motor, the Z or Y motor hooked up to the controller. We have the Y limit switch hooked up to the controller. I do believe, I don't know if there are 1 or 2 limit switches. I see, oh, no, wait, that's just a wire router. Oh, no, there is. Yeah, you can see it now if we move it a little bit more. So there are 2 limit switches per axis. So you have one there, and then you have one back here as well. So that's good. So some, I think, just come with 1 limit switch, which I think is silly. But I don't know. I might be wrong. I could just be talking out of my butt right now. So, all right. So installing the spindle. We're going to take our motor mount, 65 millimeter, and 4 by 18 socket cap screws, which are going to be these guys. Oops, I took the little divider out. All right, so we got 4 of those. What did we do with, there's that. All right. And then is there a particular side? So by the illustration, it looks like the open side goes on the left, and we're going to mount it up to these guys right here. And this fits inside, so the screws will go in from here and fit nice and flush once the spindle mount is mounted. And it's nice anodized steel, pretty nice. There's no like sharp edges on anything or whatnot, so that's a good thing. I don't want to turn this so that you guys can't see anything that's going on. So this is going to be our power to the spindle, I'm assuming. So we can use this little cheapie to get these in. So far, we're 46 minutes in. It says that you should be able to build this in about 15. Like I said, I'm not that smart, and I'm also trying to kind of narrate this and figure my way through it. So tripling up the time probably isn't the worst thing. Oh, but at the same time, it should have been probably done by now. Appreciate you tuning in on this. Hopefully this helps somebody. I don't know. That's kind of the way I look at it is if somebody buys one of these and has no idea what they're doing, well, welcome to the club, buddy. And like I said before, if I can do it, you certainly can. So I'm going to tell you a secret that I was going to save until later, but I haven't even downloaded any control software for this yet. I am literally starting from scratch. This does have its own kind of proprietary software that they recommend, something like Hummingbird or some, I can't remember what it's called exactly, Sparrow, Finch. I think it was some sort of a bird. But I've heard mixed reviews on it. Some people say it's adequate. Some people say it's trash. Also, my buddies over at Lightburn have released Millmage as a release candidate. I'm not sure it's 100% out yet for people to actually buy and use, but I've heard at least that it's out as a release candidate. So that's just kind of like a fancy name for beta. So Lightburn, the guys who do the phenomenal laser control software, have been working on and promising a CNC control software for a few years now, I think, is when the cat came out of the bag. They announced it either at or prior to, I think they announced it at Lightburn Experience in Peoria, Illinois back in 2023, and kind of surprised some people, and I guess some people had kind of known it was coming, but hadn't really much progress since then until a few months ago. I think they started the release candidates, and so I think you can go on and kind of be like a beta user and help them figure out the software and maybe work some bugs out of it and whatnot. So, all right. So I think that's that. And then the next step would be, I'm assuming, to get the spindle into the adapter. There are some indexing marks here. I'm not sure which is for which, but we've got it attached. And then it's not showing how to anchor it. The same M4. Yeah, M4 by 18 goes into the side. It doesn't say quite how to index it, so I guess we'll leave it loosely mounted and then remind ourselves before we hit fire on anything that we need to tighten that down. But I'm imagining that this would change given the length of any bit that you're using. You might want to adjust that, because if we drop this Z-axis all the way down, there you go. So the Z-axis is all the way down, and then you can't really see it much, but there is a little bit of a gap here that some of these bits, depending on how long they are, might be too short, might be too long to get a good zero on. So did I cover up that? What did I do with the little crummy? I did cover it up. So it's here. So we can feed this in and not really tighten it down too much. Just enough to maybe hold this. You don't want to go too tight with just one end. There's the other one. I've always been taught, kind of go back and forth with tightening these down so that the pressure is even, as opposed to going too tight with one and not tight enough on the other, or pinching something. So we can do that. And then because that one's cinched in, this one's nice and loose. Do a couple turns on that. There we go. We no longer need to support it. It's pretty well in there. I might invest, to be honest, because I noticed with some of these when I was doing with this little Chapman screwdriver, some of these bolts were kind of, I don't want to say they were starting to round out, but it felt like the bit was digging into the metal. So what I would probably be most comfortable with is maybe going to my hardware store and getting some of the black hardened steel ones. I don't want to tear up the aluminum with the threads, but I feel like maybe the caps on those might be a little bit less prone to rounding out. So I don't know. We'll see if that's necessary or not, but this is pretty well sturdy now, so we'll be good there. So now, per the installation guide, once install the collet, etc. We've got everything plugged in. Nope, not everything. Where's that? There it is, right there on the side. All right, cool. So we have. Wonder why they gave us an extra. That's interesting. Because we have the power supply over here that plugs into the side of the controller there. So you need two plugs for this, essentially. You need one plug to plug into the controller and the power supply for that. And then you need one plug for the router bit, or for the router or spindle or whatever you want to call it, to plug into. So you need two free plugs for that, which I don't have at the moment, especially one that's going to provide 700 watts. I have everything plugged into my little Blue Eddy right now because I'm not really near a plug, and unfortunately that's not going to hold 700 watts. So that's off. I'm going to grab a quick extension cord real quick and see where I can plug it in. Actually, I think what I could probably do so I have this cord here that we could plug the spindle into, and then I have another cord, or rather I could probably plug the controller into my Blue Eddy. So quick test. Yep, she turns on. It's alive, sort of. All right, I'm going to try and get this situated so hopefully you guys aren't staring at just a bunch of wires. So hopefully this can plug into here. Pardon my reach. All right, so we have a light on the power supply. Hit the switch on the back. We have light on the controller. Ta-da. So that's good. So it would appear to me, ladies and gentlemen, that we have successfully assembled, at least, our Jinmitsu 3020 Pro Ultra. It's a mouthful, huh? For the very basic assembly. And now, they gave us 2 wrenches for installing the collets. And if you're not familiar with this kind of stuff, the collet is the little metal, like fingered thing that holds the bits. So, like when you're using a hand drill, like a power drill. So, like my little Porter cable here, when you turn this, these fingers here will tighten or loosen, and then it holds your pieces in place when you're trying to do things like drill or use screw bits, whatever. The collet essentially does the same function, just with more points of contact. And then what you do is you put it in the bottom of the router, and there's a nut that screws in. Let's see. Loosey. So what happens is this goes up inside, and then this, as you tighten it, tightens these fingers around the bit and holds it in place. So you have more points of contact and more torque because you're actually tightening the screw in. And that's how the bits stay in the router when you're using it and don't just spin inside the shaft. want to make sure I have the right, let's see. Put the collet in. Oh, okay. So I just showed you upside down. So the collet actually goes with the long side of the cone up and then the short cone down. So sorry about being misleading there. So we're going to drop that in and move that up. So the smaller wrench holds the shaft in place while you thread this up. There you go. And then when you're ready to actually lock something in place, you just turn this righty-tighty and it will lock. So, hooray! Congratulations, we have already completed the building phase of today's program. I thought there was, oh, you know what? No. There are people that have 3D printed cool little stands that this can fit into and will like T-nut into the side of the extrusion here. That might be something I look into in the future. Haven't really made up my mind on that at all, really. Let's make some chips. Yeah, buddy. Sounds good to me. All right, so that's done. We need literally right in front of me. Wow. I just did the whole walking around looking for my phone and turning my phone on as a flashlight to look for my phone. This was right in front of me. Holy smokes. All right. So if we look at our controller right here, next to the power cord is where the USB type B goes into. There we are. Yeah, that thing's beefy. Pretty happy with it so far. I obsessively watched videos and did research on this thing before I made the decision, so I was pretty sure I was going to be happy with it, but having it built here on my desk and everything now just kind of reinforces that. I will need to make sure I either move my computer in relation to this when I actually use it or get a longer cord because this bad boy is about stretched to its limits. And my camera is plugged into one USB already. So, boom, there we go. We have a new device. All right, so install the driver. I'm assuming that's on the micro SD that they provide. But I don't like plugging in USB drives to my computers. So what we're going to do real quick is download that driver. So we're going to go to Google, Genmitsu, what the hell? Genmitsu 3020 Pro Ultra drivers. So Sane Smart is like the parent company for Genmitsu. 3020 Pro Ultra resource page. And then boom, driver. I don't know why I'm more comfortable downloading a driver from a Chinese website than I am downloading it from a Chinese USB drive, but that's my mental illness. All right. Set up. Doing our exe for driver installation. Install. Well, this is a very Windows 95 looking driver install successful. Okay, cool. So we have now successfully installed the drivers for this. Now we have to make a choice. Are we going to take their controller software, which is, oh, it's Candle. I wasn't even close with the bird name. What a dummy. It's called Candle. Why did I think it was like Hummingbird or something like that? Wow. Yeah, so that's what you get. So we can install Candle, which is their Gerbil control, or we can go back to Google and we're going to type in one word, Millmage, Millmage, and we're going to do, what is it called? The release candidate. All right, so on Lightburn software, they have the Millmage release candidate. The first public release candidate for our new software for CNC users, Millmage, is available for download now. Oh, this was in June of 25. I thought it was like late 25 for some reason, but yeah, so midway through the year, they made that available, and it appears to still be in beta. So it says here, warning, the current version of Millmage is a release candidate, a stable version of the software that is nearly ready for official release, but in need of additional public testing, which is what we're going to do. And what better way to test something than to have a slack-jawed knuckle dragger try it out. Download Millmage release candidate 13. Wow, they're up to 13. They've been doing a lot of updating apparently, huh? So we are, because I am a Lightburn fanboy, we're going to download Millmage. Might add a couple extra steps to having this thing up and running, but as opposed to downloading some possibly subpar software and dealing with it, I think it's probably better that we just go with what we would rather use in the long run and learn how to use that rather than try to learn to use something and then switch to something different. You know what I mean? Am I making sense? Know what I mean, Vern? All right, so we are extracting files and installing. Ooh, it's official. We peeled the film off of our cereal plate. It's ours now. All right, so we are going to launch Millmage. And had I used, oh, you know what? I think I can, because originally I was just going to go straight through YouTube, but I did go through my StreamYard account. Start my free trial. Welcome to Millmage. If you've never run Millmage, the first thing you need to do is set up a device type in the devices box. We'll take you there next. If you have more than one type of device, you can add more than one and choose a default, which is just like the Lightburn software. Many features of Millmage are modified depending on the device you have selected, so this is a necessary first step. If you need to reset your device connection, simply open the devices menu and select OK. All right, it'll disconnect, reconnect. All right. This is not your first time. It is highly recommended you to delete and recreate all devices. Oh, so that might be because it's a new build of Millmage. They might not have an effective way of importing installed devices or something. So our device list. So I guess we'll create manually, and it'll be serial/USB custom G code. So we're going to call this, what do you want to call it? We're going to call it 3020 Pro Ultra. And we're going to use metric. The dimensions of our work area, our x-axis, which is left to right, is 300 millimeters. Our y-axis, I think they said, was 205, right? Next. So our G code is Gerbil. Yep, it's just Gerbil. Let's refer to our manual and see if they have any special baud rates or transfer modes or anything like that. So it says to install the driver. So under baud, it says 115200, which is actually the correct number. Look at that. Hey, hey, hey. All right. So I think that's all we really need to do. So we're going to go next. Origin at rear left. I think our origin might be front left. I don't remember seeing it say anything about origin. So, require set up the COM port and baud rate. Software should automatically select the port number, baud rate. Click OK to save. 3D preview interface. No, I'm not seeing anything that says what that anything needs to be specific for the home. So we'll leave it at that. At rear left. Finish. Okay. Welcome to Project Setup Wizard. Select the machine you're using for this product and hit next. All right. The measurement units you prefer to work with are millimeters. CNC router projects work best with high quality stock. Accurately measure the stock. Ensure the stock is already fastened in the machine workspace before operating the machine. Huh. Okay. So, do we have something? I know we have lots of things, but I don't think I have anything that's like a specific size. I bought some wood, but it's way longer than what the measurements would really fit. So I bought this specifically just to mess on because I don't even know why. I can't say it because. So let's break out our handy dandy caliper. And we will input, we'll leave, I guess, the X width, or we'll just make up a number for the X width. I don't really care. So these are 37.24 by 8853. 37.24 deep. And height, I guess, or what was it, 88.53? 88.5. Width, we'll just call it 100 millimeters. I'm not really tripping, whatever it is. I wonder if this is going to be a problem. Because these... do these work even? I don't even know. Doesn't work like that. I know it was in the book. So, there's an M6 nut, aluminum column, aluminum plate. So you put the nylon gasket, the spring on the shaft. All right, so the correct way to do this, because I know you were wondering, is to take the rod, put your spring on it, put the nylon washer on top of that, take your arm, set that down, take your T-nut, set that down, and then you're going to put the shaft or the nut on top of that, and that will tighten. We'll have to do it on the other side, obviously. Yes, I have been watching Stranger Things. So I was just whistling that little tune like a knucklehead. All right, so that's that. Put the spring down, put that guy down, put that guy down, put that guy down. And then why do I have the feeling that I will be sending something launching before too terribly long? Probably need another one down here just to be safe. All right. Welcome, guys, to my impending doom, starring me. Who's about to catch a 2x4 to the face. Just kidding. Hopefully. JK LOL, maybe. Maybe I'm just seeing a glimpse into my future. All right. Phenomenal. I haven't looked at the comments. Somebody's probably screaming at me right now that I'm doing something wrong. Let's pull that up. How you guys been, my one viewer? There we are. Let's see. I wouldn't trust USB drive. USB drive that came with my 100-watt fiber container backdoor, the auto install. Yep. Thank you for validating my concerns, Mr. Kevin Murphy. I appreciate that. All right. So, hey, we're up to 2 viewers now. Yay. All right. So screw this down. And it seems to me that we're not quite tight enough yet, but there we go. Still not there. Did I do something wrong? I thought 3 might be enough. Maybe I'm just not smart enough for this. Yeah, we probably need to do the fourth one too. All right, well, you know, I really don't want to send anything flying, so let's do it. I think I am missing one of the little plastic washers though. Oh no, it's just in there with my Z probe. Better safe than sorry. And spring and washer. I think I'm going to end up getting. I should have bought some in advance, but a lot of people use like the tape that I use for everything. This stuff and super glue basically. And so you put the tape on your spoil board, put the tape on the item that you're going to be milling, and then super glue those two pieces of tape together. And that magically has the holding power to keep shit from popping up and hitting you in the face. So there, now as you can see, sturdy. All right, so back to mill mage. We have our dimensions put in. Establish the Z-axis 0 point to the location of the tip of the router bit, either by touching the tip of the stock or at the bottom touching the waste board. Okay, so basically what we're going to need to do, top, next, identify the project origin, front left. So I don't know if this is product origin, so front left, okay. So now we have to make sure our safe clearance height. So our safe clearance height is going to be basically how it can approach. So I would go from the tops of these knobs to the top of the surface. So if we take the top of the knob and the bottom of the knob's pretty much flush with the wood. So that's sitting about, we'll call it 11. We'll go 11 millimeters above the wood. It's set to 20, so that should be fine. Fast reaction height is the distance above the stock to lift the router bit when moving. Fast reaction height, let's set that to 20 millimeters too. So it's going to pull 20 millimeters up and then move. Maybe that's too much. What was it at 5? All right, we'll leave it there. All right, pocket lift height, 5 millimeters. That should be fine too. All right, so I guess we're going to import. I'm going to look for beam it up logo. I wonder if this will import Lightburn. Let's try it. Hey, look at that. It sure did. All right. I guess what I should probably do is see if maybe I can present, share screen, Millmage, share. All right, so is that sharing? Oh, it's sharing the damn website. My bad. Let's get rid of you. Stop screen. So let's present, share screen, window, no image. There we go. Share. Sorry, I'm still trying to get used to this. All right. So hopefully you guys see what I'm seeing, which it looks like you do. Yay. So I took my logo and let's see. Go back to no image and imported it. So the benefit to this is a lot of the look of this is going to be the same as what I'm used to. So I'm going to go with a 50 millimeter, beam it up, and then operations, new operation, and we can inlay female. All right, cool. So inlay female, tool diameter, tool length, number of flutes. Oh man. So if we pick one of these deals that it came with, let's find one. Dang, dude. So looks like these are maybe just all like V-carve bits or whatever they call them, the V-shaped ones. Yeah, looks like they are. All right, so pretty much all the same, it looks like, out of this kit. I haven't broken open my other one yet. So we're going to zero our calipers and measure 3.17 millimeters. .17. All right. So our tool is 3.17 millimeters. Select tool. It's not an end mill. I wonder if we have to. Import. Oh, here we go. So V bit, 12.7 millimeter. No. V bit. It's not a 12.7 millimeter diameter though. It's a 3.17. So can we make our own? So we can add a tool. No, we can't. So we add geometry, V-bit, diameter 3.17. And as far as the length, the V is 16.89. We just call 16.9. So how do I put that in? Flute length. It won't let me alter the flute length. Wish it would let me alter the length. It's crazy. All right, well, maybe that's something we'll try and figure out later. All right, so select tool. Oh, I didn't do it. So we need to go back here. Add. Oh, wait, maybe we can edit it. Yeah, let's go back. Select tool. And then there was an edit function. So maybe that's like a 45-degree V. And then we can edit it with a diameter of 3.17. I just wish it would let me do the flute length because it's not. Would a 60 be longer? 60. I don't know. Didn't save our operation either. Inlay female. Select tool. VBit. Edit. 3.17. Vendor, tool number, diameter, flute length, number of flutes, tip radius. Oh, included angle. So the smaller the angle, the longer it goes. All right, so that's how you change your flute length. What did we say it was? 16.89? Oh, no, that can't be right. That's just that part right there. So that part right there is like... It's more like 7 millimeters. All right, that makes more sense. I didn't realize it straightened out. All right, so we'll go with 7. This still seems like too much. Oh, it's 7 degrees, you dummy. All right, so what gets it to 7 millimeters? 25 degree. All right, that'll work. So we'll work with that. That seems a lot more. Yeah, for sure. All right, so how do I save this? Apply changes. Boom. And then go to OK. All right, so we selected our tool. Clearing pattern offset, cut direction climb, feed rate 600 millimeters per minute. I have absolutely no idea how feeds and speeds work yet. Shit, I didn't mean to do that. We'll open that up. So feed rate 100 millimeters a minute. Ramp feed 120, spindle speed 100 RPM. No, we're gonna go. I don't know. What should I do? 1500 plunge. So that's how plunge rate. We're going to go conservative at like 25. All right, cool. So then we've got this guy that is 50 millimeters. We're going to make it like 44. All right, so how deep? Start depth and final depth. So our start depth is 0. Final depth will make. So I wonder. So our final depth. Okay, so we'll go 3 millimeters. Okay. So then can we frame? Has no toolpath created for 30 of the assigned shapes. There's a strong chance the bit is too large to fit in the geometry. So I just picked something that's too difficult to do. All right. No, I don't wish to continue. All right, tell you what, let's get rid of our beloved logo. Let's just do something simple. let's go and do a pentagon. Shift, hold it open, and this will be that. So can we frame now? You have no operations in the project set to output. All right, so how about, nope. So we're going to take you, how do I make you assign? So take you, click you, assign. Replace the shape assigned to this operation with the current selection. Boom. All right. So now can we frame? Okay, so we didn't get anything. What if we go to move? Because we turned the control board on, right? That's off. That's on. So are we connected? Hide console. Oh, e-stop is activated. Duh, I forgot about that. I accidentally pushed that when we were doing this. Okay. So let's go back to move. Hey. All right. So we are slowly but surely getting this figured out, huh? So let's take our I wonder if this collet's already too tight. It is. So take our collet. And then slide this bad boy. All right, so let's put this in there. And then, bam. All right, so we have our bit in, and we are about to tighten it up. Boom. All right. And now let's do our Z movement. I'm going to take it down to 1 millimeter at a time. Oh, too far. So that looks all right. So position. All right. Jog. So if we go like this, oh shit, too far, too far. This is why you don't buy a fucking 2 foot long 2x4 to test on, guys. All right, so zero workpiece, and then what happens if we frame? Okay, we almost had catastrophe on our very first try. Good thing this wasn't locked down very fucking tight. All right, so what we need to do, ooh boy, Put that on the long list of things not to do, ladies and gentlemen, because you do not want to run your brand new unused bit into your brand new unused clamps. All right, so what we're going to do is leave everything the way it is. I'll move this damn clamp. The whole super glue idea sounds a hell of a lot better right now. I'll tell you what, I just had pucker factor 5 in my old B-hole. And that one's going to stick with me for a minute. Like I said, hey, if you watch this and you're like, this guy can do this, surely I can. And that's more or less the lesson of today, is if my knuckle dragging, mouth breathing ass can figure this out, surely those of higher levels of sophistication can. All right, so there we are. We got that clamp back in place. All right, so let's turn our spindle on. And hit start. Oh my Lord, I made the world's smallest. Oh no, I didn't. Okay. You probably can't see this, and I'm terribly sorry. Oh, you definitely can't freaking see it because I've got presentation on. All right, so let's switch back to you. So yeah, you can't really. Now we can see it. Yeah, sorry about that, dude. Oh, you were talking about the screen before, anyhow. So Kevin Murphy said I would just use double-sided tape with the hold downs you have. Yeah, that's a possibility. I think I went way conservative with my speed and my feed. But you know what? I would much rather be conservative and not screw anything up than be aggressive and screw a bunch of stuff up. So we're doing stuff. I'm wondering if I move this. You probably still have to see. Nope, the spindle's still in the way. Doggone it. All right, well, just in case you're not sure, we have something going on. We're removing material. So, yay. I think I definitely put the speed a little bit on the low side, but like I said, I wanted to be conservative and not break anything. So, yeah. All right, my RPM's turned like halfway up. I need to look up what the RPM settings are on this thing. Let's see. It really doesn't say. Yeah, I'll have to look that spec up. All right, so yay, we did something. I don't know what we did. Maybe we can go back to Millmage and let's see, add back to stage. All right, here we go. Oh, so you can see now we got that set up. All right, cool. So go back to Millmage and we're going to exit out of this. Oh, cancel. Sorry, my trackpad's kind of stinking today, I guess. So layers, operations. All right, so let's change our final depth to 8 millimeters. And then let's go back here to move. And then let's move our so there. All right, I don't know if it's my gloves, my machine, or if it's Millmage. Things are starting to get a little bit laggy. 0 workpiece Z. All right. So let's go 10 millimeters up. So I set the 0 to pretty much the bottom of what I just did. So now let's go frame. All right, looks good to me. So we're going to go ahead and process again and start. See if the extra depth does anything. Oh, shit. Hoping the extra depth clears things out. We get deeper with our tool. Because honestly, with a 7 millimeter tall bit, only going 3 millimeters deep didn't really clear out the 3.17 millimeters of tool width, I guess. So we have to go like at least 7 millimeters in for it to actually clear everything out. So I don't know. I could be wrong. I probably am using the wrong tool. So maybe next time, maybe next time we just swap out tools. I don't know. It's doing something. So I wonder, this is most definitely the wrong bit for this. I wonder if we went. Oh, no, that's minimized the whole window. So how do I get out of this? All right, so what I'm going to do is I think we need to rethink what we're doing. Because, I mean, at least with this bit, this is just completely the wrong. Oh, limits. Yes, I know. We hit our limit switch. So we can move 1/10 of a millimeter down. Now we're off our limits, right? All right, so I mean I really wish I could show you, but here's what we can do. It cleaned out a pretty decent hexagon. It just the bottom's all knurled up because it's a V bit, and obviously that's just not. Back to edit mode. So I don't know if you guys can see. It's real ghetto taking a video of my phone, but whatevs. So you can see here, it did a pretty decent job at making like a nice hexagon. It just didn't really, the bottom's all gnarled up because it's a V-bit. V-bits are designed to like do text and stuff, right? So let's just do something here. Let's do, instead of trying to clean out a shape, let's just do text. It's a start. Yeah, I appreciate that. It's something, right? Like I got it set up, I got it running, I got everything going. So at least like, yeah, thank you very much. It is a start, and it's definitely more than I could do, 2 hours ago, an hour and 57 minutes ago. All right, so let's get rid of that. So get rid of you. All right. And you guys probably can't see anymore, can you? So let's go back and put you back to where you're looking at the software. So shrink you back down. There we go. All right. So if we go back to MillMage, and then let's just go and type something in. How about my name? Why not? Let's pick a fancy. Let's do ampersand. Boom. We're going to do my name in ampersand with a height of, I don't know. How about 15 millimeters? And then let's move it to, this is why I love this so far. So move to lower left. This is so much like freaking Lightburn. I love it. So we're going to hit frame. Oh, you know what? We don't have operations. We don't have an operation set yet. So we have our name highlighted, and we're going to go to assign. So if you have the object that you just made highlighted, then you click on the operation, and then you pick assign, then it assigns that operation to whatever it is that you just highlighted. So what I'm hoping is this will move up far enough without actually running into my frame. So let's frame it. Did I unassign it? All right, so then let's frame it. For Pete's sake. Let's go up and over a little bit. Frame it. Operation has no toolpath for 7 shapes. A strong chance of this too. All right, we picked too fucking fancy of a font. Pardon my French. All right, let's go back to Arial. Frame. No. All right, so it's still too small. So it can't create a fine enough design with my bit size. So let's do this. Let's go 2 millimeters deep. Framing. All right. So it doesn't appear like there's going to be anything in the way. So let's go back to move. And let's go down 10 millimeters at a time. Oof, all right. So a lot of people like to use a sheet of paper, right? So let's take. Let's take this sheet of paper, and we can still move it a little bit. So we're going to go 1/10 of a millimeter down. Oh, there we go. We're catching. So now we're a sheet of paper away from being dead on. So that is our workpiece Z. So we're going to go up to 0 workpiece Z. God, I wish I could talk. All right, so now we can go back up a millimeter. Let's go back up 10 millimeters. And then hit frame again. All right, so it appears that this is going to be like in the middle of kind of a knotty looking area. So let's go up and then let's frame that. All right, I love it. So we're going to go 2 millimeters deep, do my name, and we'll be fine. So let's go to process, and then let's go and change the camera so you guys can see some action, even though you're not going to really see what's going on. I wish I need to rethink my camera settings, I guess. Sorry, guys. So we'll hit start. The cuts weren't as smooth as I was hoping for, so I tried cranking up the RPM to see what happens. It looks like it's smoothing out a little bit. I'll need to look up and see what the numerical equivalencies for RPMs are, but oh, what happened to the camera? All right, sorry guys, I don't know what's going on, but my camera just lost connection. There we go. Sorry about that, everybody. Pardon my messy workspace. There we go. Good grief. That was crazy. Sorry about that. Drone footage. Yeah, I have a PTZ camera that I mounted to my ceiling for things like this, but I think I need to move it over so it's more at like a 45-degree angle, and I'll be able to actually like see the work that's happening, or you'll be able to see the work that's happening. It's a work in progress. Like I've said, I had to shut down my shop, so trying to set everything up inside my garage has just been challenging. But good to see you, Andrew. We did a pentagon, but I'm using a V bit, so the bottom wasn't really clearing out too well. So I decided I'd do a name since that's kind of what these are good for. Yeah, I don't think mine. Honestly, don't even think my garage right now is 53. My garage is somewhat insulated. It's insulated on one side by the ground and the other side by like thick insulation foam, like the panels. But the windows need to be replaced really. So and plus I keep my exhaust pipes pumping out the windows, so that helps keep it nice and chilly in here too. But yeah, most of the time I think 15 Celsius is about what my garage is at. And I only know that because that's what my laser chiller says when I turn it on. So I have a heat vent in here, and I was looking at Amazon. They have like Vivor diesel room heaters that you can buy for like $150 and run those. So I was thinking about maybe tossing something like that in the garage to keep it extra warm in here, make it a little bit more manageable. Maybe that would work for you too. Yeah, but my windows where they slide up, it leaves a gap in between like the frame and the window too. So I got to figure out a way to fill that in, and it's just kind of a pain. But yeah, I know I definitely, as you probably saw just now when I was fixing my camera, like there's a lot of work that needs to be done in my work area still. And now that I have this up and running, I'll probably be more encouraged to do that kind of stuff to try and get a permanent spot for this bad boy and finish getting my laser work areas and stuff established too. So yeah, there's work to be done. All right, so we'll go back to edit mode, and I'm gonna move this bad boy over so maybe you guys can see. That's probably enough. Oops, I just launched Lightburn on accident. Twice, I think. Damn it. Oh, it's funny. So Alt F4, Alt F4. All right, so let's go back to our right, so as you can see, hopefully, bam. So we got our pentagon that it looks sharp on the edges, but it's just the bottom of it didn't. Yeah, I am trying out Milmage. I was like, man, I could try and download this candle thing and see how it works. And that's the software that Jinmitsu offers. But then I was like, why learn that when ultimately I want to go with Milmage anyways? So I just, as we were doing the live stream, I kind of like, I wanted to do it under this premise really is like, I'm just a dumbass. So let's buy a CNC machine, not do any research on it, put it together, not knowing how to put it together. I've watched some videos on how to do it, but it's still, when it's here in front of you, it's much different than, watching a video. So basically it's just like, if you buy a CNC, how do you put it together? And then what are you going to run it with? And I literally debated whether or not I was going to go straight to Milmage, made the decision live on stream, and installed Milmage live during the stream, installed the drivers, set up my machine from the get-go, and we started kind of experimenting. So this is the culmination of that. It's still a little bit on the rough side. I wonder if we ran it again. I know that there's ways to like run cleanups and stuff like that. So I don't know if maybe we ran it again with a tiny offset. I wish there was a way. Let's see, operations, Emily female. Let's do a new operation. And would profile would probably be like, you think that would be select tool, VBit, and then okay. I don't know why this is all running larger than my screen. I must have to mess with my resolution settings or something inside Milmage. It thinks my screen's larger than it is. And so cut direction, climb, side, not set. So side, along line, inside or outside. Let's go outside, I think. And maybe that'll just clean it up. Feed rate, we don't want 600. Let's do, I don't know. What did we do for the last one? 25. So let's do 75. Ramp feed. Spindle speed doesn't matter. Plunge. We can leave the plunge fairly high because it's already done. So cut direction, climb, conventional. Climb. Conventional. I don't know what the difference is, to be honest. Stock to leave, toolpath direct. Start depth 0, final depth 2, because that's what we did last time. No. Why does it have the exclamation point there? Depth per pass. Entry type, zigzag ramp, spiral. I don't know. Let's just try it. Fuck it. Why not, right? So we're going to try the profile. Process. Start. Oh shit. Turn it on. Stop. So we're gonna stop. Why does it do this? Full screen. There we go, edit mode. And then let's go back to move. I think I needed to start at 2 millimeters deep because that's what it was. So let's move Z distance up. There we go. So let's go back to operations. I'm still trying to figure out all the nomenclature and shit like that. So apologies if I'm making you guys want to beat your head against the table. So start depth 2, finish depth 2.5. I don't know. Let's see what that does. Oh, you know what I think it's doing? Shit. Stop. I think I need to turn off the one. What the hell, dude? Why does this do this? Get out of edit mode. So we're going to turn off the inlay. I thought if I just clicked it, it would do it, but yeah. So now let's turn this back on. Move 10 millimeters up. It might be because I have one thing I'm trying to do 2 processes for. I don't know. So we're going to assign profile process. All right, tell you what, let's just get rid of the female. Trash you. So now there's only one. There we go. Process. There we go. All right. Start. Oh, blew out the A. So, yeah, I screwed something up. Stop. All right, well, I need to learn what the processes and stuff are because I thought the profile was just going to clean up a little bit of the outside. So, I don't know. Bummer, but well, I think a couple hours deep, and now what I'm probably going to do is sit down and learn MilMage and figure out what the different processes and stuff are and how things work and watch a bunch of videos. But we have our Jinmitsu 3030 Pro Ultra with 710 watt spindle set up running. We did 2 successful engraves depending on your definition of successful. We were just using the V-tipped bit. I have, look at that. I do have like a 40-bit set that I need to track down because it's been sitting around in my house for 2 months, and I have 5 kids and a wife that likes to move things. So I will get on finding those and maybe use like a fluted bit for the next video. But rest assured, there will be more videos and some cool projects that I'm going to be doing with my new CNC mill. So thanks for tuning in, everybody. I really appreciate it. I know this is kind of trash, and I apologize, but like I said, I kind of wanted to just set this up and get it going and kind of do it under the premise of I don't know nothing about CNCs, and like Andrew said, know absolutely nothing about CNCs. I literally know, besides watching some YouTube videos, and I think I watched one video of a couple guys, Jack in the Shop and some other dude, trying to like troubleshoot his mill mage working with his machine. I knew nothing about mill mage, but it's cool because it's very close to what Lightburn is, and I think that's going to be really helpful. So thanks for watching. Hopefully this might help somebody in the future, and I look forward to more stuff coming out. Have a great weekend, guys.